One, two, three. Yes? Everyone can hear me? Okay, so I think it was a great introduction to have the previous session here, explaining some context of Edge AI. So in this session, we would like to create a discussion on the Edge AI use cases that are successful or not. We will see that. And for that, before I get into introductions and to everything, I prepared something more interactive. So if you scan this QR code, okay, you're going to be able to, actually, I tried to make it anonymous, but you will be able to reply some of the questions I'm going to ask to the panelists. I want to have your point of view on this, and if you want to ask questions as well to the panelists, you can do it from this. Okay, so during the introductions now, I think it's a great moment. Let me know if it works or not, the QR code, and you can start interacting as well with us. So we don't have a lot of time, so I want to go really quick on this. My name is Marc Pous. I'm developer relations of Edge Impulse. And I'm going to be moderating this session. And I really love Edge AI use cases, IoT. I have been on IoT so many times. So I would like now that you do like a super quick introduction, and you tell me as well your favorite Edge AI solution that you have seen in your life. So let's start with Pete.
Pete Bernard, CEO of the Edge AI Foundation. Favorite deployment, I saw something really cool in Japan on aquaculture that was using Edge AI for fish farming.
Rahul, Mehra, one of the founder directors of Consult Red. We're a system integrator actually deploying Edge solutions into the field. My favorite one is really low level, probably talk about it, is cardboard tube cutting.
Hi, my name is Luka Mustafa. I'm the CEO of IRNAS, an engineering company where we build hardware and put firmware on it with AI models from Edge Impulse and other people. The most interesting application for me is actually putting this on an animal and recognizing what it does from motion and sounds, because there's no other way how to do it otherwise.
Hi, I'm Turasov. I'm with Edge Impulse. I'm a solutions engineer. And the use case, my favorite one is also with animals, with the tracking the collars, what the pets do, as well as the identifying cats from computer vision. So not just finding the cat's face, but there are models that people manage to put on the Edge device where the cat 1 versus cat 2 is identified. So that was pretty interesting to work with.
Okay, I thought that you said that humans were animals, and you wanted to talk about wearables. So let's do a couple of questions here. So I would like, before on the previous talk, so our colleague was sharing now about Edge AI, context and technologies and so on, but I would like to know what are the industries or domains that you see that the fastest adoption on Edge AI? Okay, and we can start with this.
Sure, I think there's always a lot of adoption in the industrial manufacturing space. Especially around automation. Those tend to be brownfield deployments where they're adding more AI capabilities into existing kind of infrastructure. So I think that's pretty hot. But we had this discussion. We have this industry working group in the foundation that's made up of all the partner companies. And, we had this big, long argument. There's just so many areas, agriculture, hospitality, restaurants, water systems, it's everywhere. So it's hard to sort of pick one big one, but the manufacturing industrial space tends to be the fastest return on investment, I think.
I'd say similar, actually. So it's around quality assurance. You get the fastest turnaround time, fastest return on investment in actually deploying a robust quality assurance strategy, because you're increasing the sort of things that you can pitch for and the quality of the items, and actually it works with you, not relying on the human factor that degrades over time or assisting that.
Yeah, I would argue particularly the best application is where industries already have a lot of data. So someone that has been collecting data, for 10 years, they have millions of samples. They know which ones are good or bad. They need a decision faster or of higher quality. That's always the strongest yield. But also interesting enough, a lot of wearables are a good application, particularly with sensor fusion. Handling one sensor is fine. You can do it with math. Handling multiple with some motion and all of that, it gets beyond normal math, let's say, and we see very good impacts in that case.
Yeah, I'd agree that the industrial AI has already reached that plateau, and we see people understanding how to use that and deploy it, and there's enough compute. But I would argue that the fastest growing indeed is wearables, but not just wearables that also work with like time series data or accelerometers, but things like augmented reality sets that, Meta glasses and things like that are reaching the compute that you can put in devices like that is reaching the point where you can deploy and run LLMs together, or either on device or on your phone, or in together, like you process some things on the device and some things in the cloud. So these solutions with wearables for humans, consumer electronics, I think is going to gain so much traction in the coming years.
I'm going to change my answer. So my favorite vertical these days is quick serve restaurants. Quick serve restaurants, so drive-through fast food, the adoption of tech and edge AI into those industries is tremendous. So through, either preparing, fries and food automatically, based on number of cars in the parking lot and things like that, determining whether the bag of food that they give you actually is accurate and using AI vision for that. So they're doing so much, unfortunately it's to reduce labor costs, but you could argue fast food jobs, kind of a tough one anyway. But that whole industry, if you ever go to a McDonald's drive-thru now, just think about all the tech that's you're interacting with between ordering your food and getting your food. There's a ton of stuff going on in that space.
That's a good one. Thank you. So I'm going to throw the script that I prepared for you with the questions, and you go directly to the questions from the audience. So what's the biggest challenge that you see in the field?
I'll start. I think, in this space, Olivier Bloch was saying he's been involved in IoT for 25 years. I think I've been there around that much time. It's complexity. That's the challenge. Fortunately, we have folks, like you guys that actually get paid to figure out the complexity, which is good business. But there's a lot of friction and a lot of complexity. And I think the more we can sort of create blueprints and paths for commercial adoption, the faster people will adopt it. So.
Yeah, the actually deploying this stuff in the field needs quite a lot of small roadblocks taking away. So it starts with the quality of data. Are you getting the data from the right place? Is it of reliable quality? Is it consistent? Can you then process it? There's a lot of conditioning. Can you get the data from the sensor to where it can be acted upon? Once you've got it, does the model work? Is it robust? And then actually, does it fit with the workflow of the factory or the company or whatever it is? So it's not just about the edge AI. It's actually about deploying it and getting it there. So none of these problems are big problems, but there's a whole series of those. And so that having a pathway that goes through is one of the frictions that needs to be resolved. And actually, people around here, we all work together in order to be able to do that.
Yeah, I would second that, particularly because quality of data is, AI is not a magic solution in any possible way, although it's perceived like that always. And the example I like to give is, you have a camera, you take a photo of something. If it's a black photo, if it's a black square, there's no magic in AI which will, enhance it to give you 3,000 pixels of resolution there. Like, unless there is good data coming in, you can't have good results coming out. However, when you come out to roll out a project, it turns out the building the model is only maybe 10% of the work. All of the rest is the complexity in processes, in getting it labeling correctly, and figuring out the user consumption, as you mentioned, to get there. So I would say lesson number one, really make sure the data coming in is good, and all of the rest kind of works after that.
I third that data is always the main challenge. To get quality data is complex, especially if the project you're working on is not in the field yet, so you're doing R&D. Like, the definition of the diverse data set is the one you collect from the field, actually. So usually you come up with some sort of solution that kind of works, but then you need to deploy it and face problems and collect more data from the field. And setting up that loop back of collecting data is also challenging, because if we're talking about Linux-based devices that are connected to the internet, it's one thing, it's easy to set the loop back. But if you're talking about deep embedded wearables, low power, that talk via Bluetooth once an hour to the phone, how do you make sure that you can collect raw data from these devices? So these questions, I think more challenges appear when you work with the deep embedded devices, also constrained hardware and things like that. How do you manage your battery efficiently? How do you schedule the inferences such that you still get the idea of what's going on but not spend the battery too much? So deep embedded is the biggest challenge, I think, implementation-wise, alongside the data. Third that, yes.
You want to change your mind, or? Okay, okay. So we have another question. This is, I think, really hard, and I think this is the time to ask this question. So, what do you think about how the new AI regulations and cybersecurity regulations are going to affect edge AI implementations in the near future? So all of these European Cyber Resilience Act and, I don't know, AI Act. I'm not sure what's happening in the US, but what do you think it's gonna affect this? Yeah, let's start from Ivan.
I have a thought. I never was talking about this, but all of a sudden I had a thought come to my head. I think that when we were talking about edge AI in particular, the benefit that is named even without things like this Cyber Resilience Act is that you have the explainability of what you're building. The models are small. The models are not in the cloud. You're not paying anyone to ingest data. It's not living somewhere. It's the model that you created yourself with your own data. You can explain and show the data and everything. So I don't see how this would be a problem in that regard. So you're just building a small feature on your device. It's not a LLM that is trained using, all the books in the world and copyright infringements and things like that. So I think in this case, edge AI, one of the selling points of edge AI is that control and that small scale that you created yourself, and it's very explainable.
So I think things like the Cyber Resilience Act, actually there's lessons to be learnt from other verticals. And so, we work in another vertical of media. And in the media department, there has been regulation about security and privacy at the edge for a long time. So actually what you need to do is follow best practices, learn the lessons from other industries and follow those best practices. So for us with, no default passwords, a secure update path, secure boot, these are things that we've done and other verticals have done elsewhere. So there's a lesson to be learned from other industries and taking that knowledge and applying it. So some of it comes from a bit of naivety and not knowing actually and not being up that curve. So.
Okay. Well, I was going to say in the US of A we don't have any regulations, so we don't have to worry about it. But so that's easy. But I think in general, the thing that's really lacking in the AI space, edge AI or cloud AI, is kind of the lack of transparency and auditability. How do you untrain models once the data that's discovered is not good or copyrighted and things like that? So there's really no way to kind of track and trace AI right now. And I think until there's more transparency, and that's an architectural issue as well as a regulatory issue, then I think it's going to continue to be sort of this black box, and people will not really understand or maybe trust the data provenance, and that I think will limit deployment. I know, like in the aerospace field, for example, data provenance, what data sets were used, where did that come from, where did the model come from, who touched what along the way before it gets into the fighter jet or whatever. These are serious issues that'll impinge deployment until we figure that out. So.
I'll just add one thing. So I think traceability is one element of that, and the other one is wraparound services. So you get those cases, failing cases, and false detections, and then improvements in those. I think that's the other bit that's going to help with that provenance and improvement and getting rid of the bad cases.
Yeah, to add on the regulation, like a good portion of all the regulations is actually common best practices, which we should all be doing anyway, and I hope everyone is doing them. So there's a bit of forcing hand for everyone to do it. But also in terms of data, like we see traceability, particularly for medical applications, from like where the sample was collected, how it was labeled, what was the ground truth, and all of that. Regulations will come in where you will be required to do all of that. But at the same time, this is also the best practice, because if you don't follow the process, you will not build a good product. So let's just hope it does not add too much of bureaucratic overhead to it, but it's not requiring us to do things which wouldn't make sense. So I think it's good.
So yeah, let's go back to the scripted question. So maybe this will be short, and we have 7 votes from the audience. You still can vote and ask more questions if you want. But which application class can or hardware can benefit more from Edge AI, do you think? So do you think microcontroller type of hardware can benefit more, or we go to more the higher end Linux devices with CPU and GPU will get benefit more from Edge AI solutions? What do you think?
I mean, it's I would say horses for courses, right? I mean, these are depends on the problem you're trying to solve. Certainly, as you go up the stack, I know the IoT analytics person before was talking about thick edge and thin edge or light edge or micro edge. You know, what we're seeing interestingly is like using like transformer-based models and LLMs, agentic AI. You know, having the horsepower to run those is going to be really interesting.
To select one,
Oh, I have to select one? I don't know. I would say spiking neural network neuromorphic processors. That's my favorite, yeah.
So I'm going to. So I think it's a hierarchy. I think it's going to be federated models, so that go from the edge and just signals that do single detection on the edge, and then signal it back, and there'll be edge compute that's running where you need the GPU and NPUs to do things, and then ultimately it'll be small LLMs at the edge, and then a secondary one at the back end. Now, where do I think it's going to happen first? I think it's going to be, I'm going to use the phrase thick edge, because I think that's where you can deploy and then you can push some of it to the cloud and some of it to the edge once you've got the use cases proved. So I think the action is going to happen on the thicker edge with NPU acceleration first.
Yeah, I would agree with that, particularly because if you want to do it truly embedded on a microcontroller, it is really hard. And you try to make the problem or the product you're building the easiest possible. So if you have the capacity, you push it to the cloud and deal with it there until you're fairly certain that this works. And then, yes, you might go for cost optimization and then push it back down to the edge to run there. But mostly you're constrained either by power or connectivity. And once you have a power constraint, usually you have a connectivity constraint, and then the only method you have available is to do it on the device. And those cases have the most added value. For example, take an image 1,000 by 1,000 pixels, and you have 3 bytes to send over a satellite network. The only possible solution is Edge AI, and the highest added value in that case.
The reason I picked the edge rather than the cloud is for latency and privacy. So that's one of the determining factors. So it's data rate, latency. That's why it's currently at the sweet spot.
Yeah, I'd say the hardware classes, both of them have been developing tremendously over the last years. I think what we call a microcontroller today has nothing to do with what we called it several years ago, and now we have acceleration on both classes of these devices. I think it's fair to say what benefits most is the higher Linux class devices, where you can also put embedded GPUs and spiking neural accelerators and whatever you have. And there you can build systems on the edge that do LLM processing and things like that. That is a big thing. However, I would say that these devices I talked about before, like the wearable, AR solutions and cloud-to-edge systems, which we would now call like deep embedded stuff, the wearables, I think the potential benefit there is way, way more in the future, because the value that people are going to get as a society in the consumer product potentially is more than industrial. It's just that it's way, way harder to build consumer products than to build the products for industry. So I feel that once that is unlocked with these classes of devices, that's going to be the biggest and the most understandable and clear benefit that we see.
So I'm not sure if we are getting to the end or not. We have time for one last question. Okay, sure. So I don't know if everyone is an Edge AI expert here or not, but let's imagine that we have people who doesn't know anything about Edge AI. So what would you recommend to them as an advice if they want to get from IoT to an Edge AI expert? So we'll start.
Yes. So you open your browser, you go edgeimpulse.com/sign up. That's the best thing you can do if you want to learn about Edge AI. But seriously, there's a lot of material in these days from, I think, all we are in this sphere. So much content, educational content as well created. And as well as with IoT before, you take a dev kit of whatever there is and you just start building. And it's so easy to create now because you just collect data, you have all the tools that are necessary that will just wrap it all for you, and you'll already be running an inference on the device. After the click is there, I think thinking what are the potential use cases that are beneficial for you, that's the best step after.
I agree, but you should really just start building things because it is so easy that like there's no barrier to entry. You do it, and then you go deeper and you go deeper, and you're years down the line still building and having fun. So just start.
Yeah, just start. The example I would give is my 17-year-old son was looking at doing a project, and I pointed him at there's it's AI 101, which is actually handwritten character recognition. Now, this is a project that I did in my undergraduate 35 years ago, and it took me 10 weeks, and actually it takes 45 minutes to do it from scratch, and you get a better than human recognition, and the data set all exists.
That's cool. I'll give a plug. So if you go to edgeaifoundation.org/learn, or you go to our website and just hit the Learn button, that's a collection of resources. It's linking to some of the Edge Impulse courses on Coursera, Harvard, a lot of free stuff out there, and we also have some career development live streams that we do there too. So I would go to the /learn and get started there. But yeah, the great thing is it's a low barrier to entry to learn a lot and to do a lot, so that's cool.
Absolutely. So we have more questions flowing, but we don't have more time. We will have Pete, Rahul, Luka, and Ivan in the booths. And thank you very much for coming here. And yeah, looking forward to see more Edge AI in the future. Thank you.